Welcome to the problem-based series. In today's series, we will review the brick making process that is predominant in West Africa. Load-bearing bricks like these are used for building houses. In Nigeria, for example, they have two variants, the 6 inches and the 9 inches blocks, as it is being called. The process of making the brick involves mixing appropriate ratio of sand, cement, and water, pouring in a mold, compacting, and curing. But before we go into the challenges I've observed from this process, let's have a look at this video that explains how this process is being made by small medium enterprises, and we can have a conversation of the solutions, of possible solutions. Before we go into the details of what we observed from the video, the first challenge that comes to mind is quality assurance of the product. In a study by Aljao et al. 2018, brick samples from 3 states in Nigeria were investigated, and it was observed that none of the bricks met minimum comprehensive strength required. While this challenge is more related to the mixed ratio, there are other factors that could have impacted or exacerbated the problem. The first observed problem is the continuous noise, pollution, and vibration the workers are exposed to. The second I could think of is the economics of lifting the molded brick the curing place. The third challenge relates to the source of energy for vibrating the machine. Diesel is used as fuel and is exposed to price variability and which impact on the cost of production. Another challenge I could think of is the emission. Looking at the location of the exhaust pipe and the standard in terms of emission standard of the internal combustion engine, the workers are more potentially exposed to air pollution coming out from the exhaust. The next challenge is the lack of PPE or exposure of the worker's skin to the hazardous chemical mixture of the cement. Another thing we could look at is the quality assurance of the brick, which is dependent on the mold. In the present setup, the mixture is made manually. Hence, you cannot establish a high level of homogeneity of the mixture. Another evident challenge is the exposure of the workers to the rotating part of the machine. There you have a belt and the pulley rotating the whole system. For any error, that could lead to an accident. The last thing I could pick from this video is the cooling method of the water, which is likely dependent on the ambient temperature. Hence, the temperature approach is not optimal, leading to high temperature of the internal combustion engine, facilitating wear and tear and possibly higher fuel consumption. These are just some of the challenges I could identify from this video. Do you think there are others, or what else can you identify? You could leave those in the comment section. While it is evident that there are sophisticated solutions already to these problems I've identified, many of these solutions are not localized and not largely available to the small medium enterprises, and possibly the initial costs of having all these modifications made to the existing process could be very high. So localization of solution, in my own opinion, in the first instance, is optimizing the existing technological approach, and maybe this could be the low-hanging fruit. So some possible questions that came to mind while I was just looking at this video is, can we replace the energy source with probably solar, which can eliminate at the same time the noise, the air pollution, and the associated health hazard? Using solar will require some reconfiguration of the vibrating system, which means a redesign in some point, but there's a possibility to reduce the specific energy demand of the existing process. We look at this from the perspective that Either you are vibrating or you are not vibrating. You load in sand, the generator is working, it's using diesel, but you could have solar PVs that only supply power when vibration is taking place. So the question might be that, oh, probably the energy required might be high. We haven't done those calculations yet, but this is open to a business model where probably the small medium enterprise does not really even need to own the solar PV. That could be another business for someone else who installs a solar PV and charge a fee per brick molded in terms of energy. Another thing I could think of is the mixture material and the standard. But I'll leave this to you. What are the possible solutions to ensuring minimum quality can be guaranteed by ensuring homogeneity of mix and the appropriate mixture ratio? We could think of also the curing and the storage. One thought that came to mind while I was looking at the video is the process of curing. Water is sprinkled upon the bricks and the water drains into the soil and it's gone. What if this water can be retrieved, captured, and be reused? From the point of view of operation research optimization, what other things one can explore to reduce the cost of production and increase process efficiency and resource efficiency? I could rather think of something of what if instead of making one brick at a time, what would be the energy demand, the system feasibility, and the constraints to produce more bricks per batch instead of just one. Another thing is the location of the molding machine with respect to the area of curing. If manual process is being used of lifting the brick, taking it to the curing site and coming back, what is the distance being moved by the worker? Can we reduce this? Can we optimize this? And lastly, how much of the bricks must be made and of which type? So basically we're looking at if we have the demand data from this SMMEs, the cost of production, then the question would be how many of each type of brick should be produced per day or per the time it's being needed to ensure that optimal production is achieved, increasing the profitability of the small medium enterprise and ensuring that all of these health risks and hazards are minimized. If I leave the question to you, what other challenges can you identify? Do you know any small medium enterprise in your area making brick? What are their processes? Are there opportunities for optimization? I would like you to share your thoughts and questions in the comment section and we can have a conversation about this process. Thank you very much for your time. We'll see you in the next series.